Good morning, everybody. So I think we already discussed the olfactory indicators also. Is it yes, everybody?
Yes,
Yes.
sir.
So we're having a 3 olfactory indicators. That is the third type of indicators we have to identify the given substance is acid or a base or we used to call as a salt. So if we take these olfactory indicators, we have a 3 substances which will come under the olfactory indicators. So olfactory indicators means in the sense of will with the help of vision or with the help of smell, everybody. It is the sense of
With the help of
smell.
smell.
That is all. So first indicator is onion. The second indicator is what? Vanilla. And third indicator is everybody clove oil. Correct? So if you take this onion, it does not have any smell with the base. It will lose its smell and it is having a particular smell in which medium? Everybody? It is having a specific smell in which medium, guys? All of you?
Acidic medium.
Acidic medium. And if you take the base, so just it will be lost its smell. So vanilla also same thing. It is having a specific smell in again which medium? Acidic medium. And you can take there is no smell in which medium? No smell in
Basic
basic
medium.
medium. Next, the same way clove oil if you take. So clove oil is different from onion and vanilla. So clove oil is having different smell in different smell for acid as well as what? As well as
Base.
base. So different smell for acid and different smell for base. That is what about olfactory indicators. So mainly a person who does not have a vision, for them, these olfactory indicators will help to identify the given substance is either acid or base or whatever it is. So this is what we studied already. Now, let us come to the next type of indicators. That is what very popular indicators. Of course, these indicators we are going to discuss once again very clearly. So this is the fourth type of indicators. What we used to call all of you? We used to say
Universal.
universal indicators. So this is the one of the best and as well as most useful type of indicators where we can identify majority of the substances by just with a single pH strips. That is what we used to call the universal indicator. So here in this you can see this is the mixture of various indicators. So just by dripping the strip of the paper, we can obtain the different colors based upon the type of the solution is given to you. And with the help of that, we can easily identify either it is a given substance is acid or base or neutral. And what is the concentration also we can identify. So that is the advantage of universal indicators. So remember, it is the mixture of various indicators. It is more sensitive indicator because it can give different colors in different mediums. So that is the advantage for this one. So more sensitive indicator as it can give different colors in different medium. So now if you notice it here, so what it will do means, so actually it will helpful to estimate even the pH. That is what we will discuss even how to calculate the pH, what is the pH also. So that is the one and only advantage of this universal indicators. So remaining all the indicators, if you have noticed, we can only identify either it is acid or base or salt. But the universal indicator will help us to identify the pH value, means concentration of the acid or concentration of a base. How much is the pH? Power of hydrogen is how much? That is what also we can identify. So this universal indicator, they will give you the reference paper strip, so which will be containing actually 1 to pH value 1 to pH value 14. Basically, it will varies from pH value 1 to colors, where it will varies from pH value 14. Even 8th class you might be have seen. And they will give you the pH paper, which will be having a yellow strips. So that is what actually the universal indicator. Yellow strips. Okay. So that is only called as actually universal indicator. And one reference chart with the color, different colors of pH. It will varies from where to where, guys? pH value 1 to everybody. pH value 14. Clear? It's not 4, it is the 14. So now, whenever, suppose I have given you one beaker solution. Now, if I dip this paper, yellow strip, always the pH indicator is, universal indicator is in yellow strip. So if I dip this yellow strip in the given solution, then it will give you, it will turns into some color, which is referred to this given reference chart. So this paper, whenever this paper is soaked into the solution, that is what this pH paper. So if you notice, immediately it will give you the colors related to this chart. Based upon that, we will understand either it is acid or base, and what is even the pH value also. Approximately, we can estimate the pH value also. Okay. But anyhow, we are going to study more in detail about this universal indicator in this chapter, as it is very, very important. But now not. Just we are studying now types of indicator. Later we'll discuss in detail. Okay, guys. So this is what about universal indicator. So what is the advantage of this universal indicator? We can estimate the pH of the same acid in different concentrations. Understand? So it will helpful to estimate pH of same acid in different concentrations. Base also, different concentrations. We will discuss these things very in detail about this universal indicator. So you might have seen this color chart. Have you noticed it, everybody? The color chart varies from 1 to 14. Universal indicator. Class 8 also it will come. Yes, guys, please respond. All of you? Nobody. If you say only correct, I can come to know either.
I know, sir.
Yeah. Very good, Omar. So universal indicator, you might be saying.
Yes, sir.
Class 8, you might have seen this, and even the books also it has been there. You can see this is what color chart. This is the universal indicator reference chart. Understanding? So now they will give you the universal indicator one strip. You can notice in this figure. So of course, even liquid solution also. So we are getting the universal indicator like this yellow color strip. So if I dip in the given solution or if I soak it in the given substance, then it will change the color into according to the given chart. So based upon the change, for example, when I dip the yellow color strip, it will turns into dark red. Then you can see I can identify what is the pH value. Even pH scale varies from 1 to 14 only in these papers. So this is what actually perfectly. So you can see that 1, 2, 3, 4, 5, 6. For example, as soon as if I dip, if it is coming green color, you can see light green color. What is the pH value, everybody? 7. Dark green color, we can say it is 8. Like that, we can estimate the pH also. So this is the colors. Of course, we people will study that very clearly. So just I am showing you now. This is what is a universal indicator. The one and only advantage is that along with the identification of a substance, we can estimate the pH also in this universal indicator. Okay. So now we are going to start. This is what about the 4 types of indicators. What are the 4 types of indicators? Everybody, please respond. 4 types of indicators are what? Universal indicators, natural indicators, synthetic indicators, olfactory indicators, and last one is what? Universal
indicators.
Okay. So now we are going to learn classification of acids. Of course, later classification of bases also will come. So please all of you keep adding classification of acids. So now, what is the acid's general definition? We studied already at the beginning of this chapter. What do you mean by acid? Everybody? What do you mean by acid? Acid means what? Definition, basic definition. I won't teach you.
The sour and taste.
Very good, Harish. Other Harish Jairas only knows. So other people don't know. If people leave from the meeting, what is the use of study then? People are nonsense people. What is the basic definition of acid? Acids means what? Which are basically sour in taste. And bases means what? Which are basically what is
Bitter
the
in taste.
bitter in
And
taste.
also
Then what is happening here? That is what. So classification of acid, remember, the acids can be divided into basically 5 different categories, but class 10th, we need only 3 different things. So that is what, based upon the availability of hydrogen ions, we will say the first category. So first category of acids we'll discuss about based upon the hydrogen availability. Okay, so availability of hydrogen ions. That is what we can say strength. Okay, second one is origin. Either they are coming from nature or coming from lab. And the third type of acids is called as amount of acid. So based upon the amount of acid, that is what we can say concentration. So these all the terminologies you might be already studied even in lower classes. We'll study strong acid, weak acid. Next we'll study organic acid, mineral acid. We'll study also concentrated acid, dilute acid. Do you remember anybody? So that is only that. So classification of acids for class 10 is 3. That is what? One is based upon the availability of hydrogen. Second one is based upon the origin. And third one is amount of acid present in the given solution. So now let us discuss first one. So the first one is based on the basis of availability of hydrogen ion. So all of you remember on the basis of availability of hydrogen ions. So if you have taken now, so on the availability of hydrogen ions, acids may be classified into 2 types. What is that, anybody? The first is we used to call as weak acids, and the opposite one, what it will come, guys? All of you.
Strong acids.
Strong acids. Okay. So that is what you have to remember. So first, write it. Weak acids. Weak acids. So remember, what is weak acids means? Those acids which are not completely ionized in water and give a very few hydrogen ions in aqueous solution. All of you remember? Any kind of acid, if it is dissolved in water, it will never be completely formed ions. Do you remember electrolysis process we studied? What is electrolysis? All of you? What do you mean by electrolysis? By passing the electricity, we will split the molecule into what? Suppose if water we are having, by passing electricity into what? Hydrogen plus oxygen.
Oxygen.
So that is what. So if it is a, by this time I have taught you, by passing electricity, we will split the molecules into ions, or that is what atoms. So if you notice it here, I have taught you electrolyte or else strong electrolytes and weak electrolytes. Remember, Amitakshri? Electrolyte and weak.
Yes, sir.
Yes, please, everybody.
Yes, sir.
So now strong electrolyte means what is that? It will split into ions completely, ionized. We used to call it as strong electrolyte. Normally, like not completely ionized, we used to call it as what we used to call? Not completely ionized. Means in the sense of fully not dissolved in the water and not forming the ions completely. That is what we used to call it as weak electrolyte. So same phenomena here. If it is partially ionized or not completely ionized in water and only gives very few hydrogens, that is what we used to call as weak acids. All of you remember that. Okay. So those acids which are not completely ionized. Ionized means what, guys? Splitting into ions. Understand, everybody? So that is what. So ionized in water, or you can say partially ionized in water, and gives you very more hydrogens or very few hydrogens. Everybody, very few hydrogen ions. Very few hydrogen ions in aqueous solution are called, what we used to call, everybody? We used to call it as weak acids. Yeah. So for weak acids, the number of H plus ions increases by addition of water. That is very, very important. So if you take, for example, vinegar, what is the vinegar acid present in that? Anybody can tell? What is the acid present in that?
Acetic acid.
Acetic acid. So if you take acetic acid, is the example of weak acid. Okay. Acetic acid is a weak acid example. Of course, we have so many. I'll say you. So just I'm saying this is what. Okay. So how to increase the H plus ions? Everybody, by adding what? More amount of water. Okay, right. The weak acids, the number of H plus ions increases on addition of water. So more water if I am adding, it will start increasing the more number of H plus ions. That is what you have to remember it. So example, what it is, everybody? What is the example of weak acids? Yes, please.
Acetic acid.
Acetic acid. So let us see the properties. So properties of weak acids. So now as it is partially ionizing or completely ionizing, guys, weak acids, everybody? Partially means in the sense of they are good conductors of electricity or they are the poor conductors of electricity. Everybody? As they are the weak acids, they are not good conductors of electricity. They are what conductors of electricity? Everybody? Poor conductors of electricity. Because of partially ionized. If they completely ionized, they are very good conductors of electricity. Is it okay, guys? All of you? Clear? Mr. Noor?
Yes,
that is one. Next, second property. This is very, very important for you people. So, right. Both ionized and unionized acid molecules, both ionized and unionized acid molecules are present in the aqueous solution of the weak acids. Okay, so that is what you have to remember. Now, for example, so if I take acid plus if I take water, so if I mix with the water, it will form what, guys? It will form H plus ion.
Salt plus.
No, it's not salt. That is what I'm saying. Remember, Vijay, acid plus base only will gives you salt plus water. Understand, Vijay? That is
Yes, sir.
neutralization reaction, not here. This is neutralization reaction, or we can say also example of what reaction, everybody? It is
Yes.
double displacement
Double.
reaction. This is not this one. So remember all of you, acid plus water, if it is acid is dissolved in the water, aqueous state, it will form what ions? That is what we used to call as H plus ions. But here I am not writing H plus ions. I am writing H3O plus ions. So this is only we used to called as hydronium ions. What ions we used to called as? Hydronium
Hydro.
ions. Okay, remember that this is only H plus ions. Later I will say you H plus ions, how they will form the hydronium ions. Okay, plus it will form anion. So as we know, cation means what? Positive or negative? Cation means positive ion or negative ion? Positive ion. And anion means what? Negative or positive?
Negative.
Negative.
That is what you have to remember it. Now, for example, let me take how it will be forming. So if you see that, for example, if I take the acetic acid, what is the formula of acetic acid, everybody?
CH3CO.
CH3COOH reacting with the water. Remember, it will form anion called as CH3COO, which is what we used to call as anion. Okay. Plus it will form hydronium ions. That is what? H3O plus ions. So that is what it will happen. So this is hydronium ion and this is the anion. So anion is what? CH3COO. Okay. Minus. So this is what is called as weak acids. So weak acids, ionized and unionized molecules, both are present in the aqueous solution of weak acids. So that is how the ions will form when weak acids will dissolve in water. So if we take generally organic acids or carboxylic acids are the examples of every weak acids. Okay, all the organic acids, or we can say carboxylic acids. Chapter 4, chapter number 4, carbon and its compounds. We people will, its compounds, will get about this carboxylic acids. Very, very important concept, functional group. We'll study by that time. So organic acids or carboxylic acids are the examples of what? Everybody? Examples of weak acids. Okay, so this is what about the weak acids. Now let me give you the examples. So if we take many examples, we can write, as we know, acetic acid is the example of what acid? All of you. Weak acid.
Weaker.
Is CH3COOH. And of course, one and only mineral acid, but under weak acid, that is what? Carbonic acid. Only mineral acid. Please remember, one and only mineral acid, but it is a what acid? Weak acid or strong acid? Everybody. Weak acid.
Weak.
That is a carbonic acid. This is a formula very important. H2CO3. Please, everybody, 2 times you can repeat and you can learn. Carbonic acid formula is, what is the formula? H2?
H2.
H2CO3. Carbonic acid. You'll definitely will forget that. Next, phosphoric acid. So phosphoric acid, so formula is H3PO4. So this is also weak acid. Next, you can take lactic acid. So lactic acid present in where, guys? You might be studied in lower classes. Lactic acid present in source. Sour milk. Milk contains or curd also contains lactic acid. Forget it. 7th class you will study. Sources of organic acid. Lactic acid is present in the curd. Is it right or wrong? Very good, Gayatri. So that is one. So the formula is CH3CH OHCOOH. So this is the formula of lactic acid. So this is also example of weak acid. Like that, all the weak acids like organic acids, you can say as an example of weak acids. Clear, guys? All of you understand? So that is what about it. Next, strong acids. Opposite to this, that is what we can say strong acids. Now yourself, you people, anyone can try to say the definition of strong acids. Weak acids means not completely ionized or partially ionized. Now here strong acids means what? those acids will become what? Everybody? Yes, please.
Completely
Completely
ionized.
ionized.
Completely ionized. Those acids which are completely ionized in which solution? In an aqueous medium. Okay. So means when we dissolve in what? When we dissolve in what, guys? Water. Okay. That is what? Medium. And give more amount of H plus ions or less amount of H plus ions? Everybody?
More amount.
Large number of hydrogen ions. Hydrogen ions also I can represent what? Just now I told you. Hydronium ions. H3O plus also. Understand? Mitakshri, Abhirami? That is what you have to remember.
Yes, sir.
Okay. So that is what hydronium ion, hydrogen ions in water. In water by the process of ionization. By the process of ionization are known as strong acids. So, examples. You all people, what is a well-known example of like strong acids? We all know from first
Hydrochloric acid.
HCl you can take, sulfuric acid you can take, so nitric acid, chloric acid. These all are the examples of strong acids. So they'll form more number of H plus ions or less number of H plus ions. Everybody will form the
More number
of H plus ions. So let us study what are the properties. So just some properties we'll discuss. So they will completely, you can see they contains completely ionized. So they contains only ions or molecules also present. Everybody, they contains only what? Ions. Understand? So weak acids contains what? Weak acids contains ionized and unionized acid molecules. But here it is completely ionized. So it contains only ions or it also contains unionized molecules. Everybody? It contains what? Yes, please. It contains only what, guys? Only ionized ions it contains. Because completely ionized of strong acids have only ions. Only ions. Why only ions, everybody? Because of completely ionized. Okay, so that is what. But weak acids also contains molecules also, unionized molecules. Second one. So they are completely ionized. So they are good conductors of electricity or bad conductors of electricity. Everybody.
good conductors of electricity.
Yeah, good conductors of electricity. Okay, so next. So now they are highly corrosive in nature because they are very strong actually. So that is the reason these acids, even metals also they will corrode, and even they are corrosive to skin also. They'll burn the skin and damage the skin more badly. They are highly dangerous actually. So these acids are very corrosive to skin and even metals also, and delicate parts of our body. It will melt it, like it will burn completely it is. And these acids, is it possible to taste it, everybody? Yes, please.
No, sir.
These acids are very dangerous. So we people cannot be taste it. Very dangerous to taste. Okay, all of you. So this is what about properties of strong acids. So you can take examples. So strong acids, all the mineral acids except carbonic acid, we can say that. So HCl, we know that. What does HCl means? All of you. Hydrochloric acid. You can take H2SO4. What is the H2SO4? Everybody.
Sulfuric acid.
Acid. If you take nitric acid, what is the formula? HNO3.
HNO3.
Okay. Nitric acid. And if you take HClO3, chloric acid. So these are the examples of strong acids which Basically, we will only deals about these two acids in the entire class 10th. Most probably nitric acid and chloric acid also will never come in our anywhere in the equations. Only two we have. That's all it is. Clear, everybody? Clear? Anyone having any doubt? You can ask me. Clear, all of you? Understand? Yes. So based upon the extent of ionizations, we can say either it is a either it's a weak acid or strong acid. Completely ionized, strong acid. Partially ionized, weak acids. So this is the first category. Next, second category. What is the second category? All of you, on the basis of what? All of you, on the basis of origin. Understanding? So from where they are coming from, either they are coming from nature or they are coming from laboratory. Either we are manufacturing. So we'll decide it is what it is. Okay. So on the basis of origin, the first category of acids which we are deciding is what we used to call, all of you, organic acids. Okay, so just now I told organic acid called as another name. Anybody can tell examples of weak acid? I told you, all of you. Chapter 4, carbonic acid. Yes. So all of you remember organic acids also we can call as what? Mr. Vijay? Carboxylic acid.
Carbonic acid.
Chapter carbonic, not carboxylic acid. Carbonic. Carbonic is one of the example. Clear? Carboxylic acids. Chapter number 4, we people will study. Okay. So that is what organic acids. So name itself it contains. It is derived from nature. Means biology we all knows. Nature contains two things. One is plants and another one is what? All of you. Plants and yes, please. Animals. So that is what. So those acids which are derived from plants and as well as animals are called organic or carboxylic acids. Okay, so these contains, they're actually, you can notice it, they're containing organic acids or we can say carboxylic acid if you take. So these acids definitely they contains the carbon. So that is what you have to remember. They contains what, guys? They contains carbon atoms. That is what you have to remember. So if you notice it, these organic acids, actually, why we used to call them as organic acid from the biology word, organisms. What is the organisms we have in our earth? We're having two kinds of organisms. One is what? Plants and another one is what, guys? Animals. So that is why as these acids are coming from these organisms, that is the reason we used to call them as what acids? Everybody? We used to call it as organic acids. So if you take examples, of course, plenty of examples you might be studied, which is coming from the nature. Of course, now, weak acids, I have taught you the carbonic acid. Is it under the organic acid? Anybody? Carbonic acid? Any one of you? No. Understanding? Carbonic acid is the one and only mineral acid. Understanding? Mineral acid, but it is what acid? Weak or strong acid? Everybody. Weak. Carbonic acid. Weak acid. That is what you have to remember. So now, so carbonic acid is not organic acid. And let us see from class 8th and class 7th, what is the acid, organic acid, and what is the source? You can see that. So acetic acid, we all know it is in our kitchen. So what is acetic acid source, everybody? All of you? Yes, please. Vinegar, acetic acid. Next, oxalic acid. You might be knows. Oxalic acid, red color. Every day you people eat. What is that? Tomatoes. Next, tartaric acid. So tartaric acid, what is that present? It will start with the tab only. Yes, please. Tamarind. Tamarind. Understanding? That is what. Next, citric acid. Citric acid is present in lemon.
Sir.
Okay, that is all. Next, lactic acid is present in, even just today also I told, lactic acid is present in You can take
Sour
Sour
milk.
sour milk and as well as